Okay, so we have this triangle, and we're adding vectors, 3 kilometers west, 4 kilometers north, which gives us 5 kilometers as a magnitude, but we also need the direction. So we have to find the angle. We call the angle theta. We want this angle theta so we can describe to someone where this person is if they walk 3 kilometers west, 4 kilometers north. So we need to do a review of trigonometry. So we're going to do a trig review right here. What's the saying with trig? SOHCAHTOA, right? So we have SOHCAHTOA. That's, you just got to remember that one. Okay, what is the sign? Oh, sorry. What does the so mean?
Sin.
Yeah, the sign.
Oh, sin.
Yeah, sin. That's a different class. We don't cover sin in here. Some sins have been committed in the frustration of physics, but we don't learn about it. Sine of theta is what over what? What's the O and the H? Thank you, Gemma. Opposite over hypotenuse. Okay, but what does that mean? What are we basing this on, Daniel? What shape? Triangle. We got triangle, right? So we're basing this all on a basic triangle. Can it be any triangle?
No.
Has to be what type?
Right triangle.
Has to be a right triangle. And if my angle theta was here, let's say. Well, first of all, what's the long side? Hypotenuse, right? So H is for hypotenuse, that's the long side. What do we call the side that's across from the angle, not touching the angle? Good, that's the opposite. So big O for opposite. And then what's the shorter side that's touching the angle? That's the adjacent. So okay. So when I say the sine of theta is O over H, that means the ratio of opposite over hypotenuse. Okay. And cosine, ka is the cosine of theta is adjacent over hypotenuse, and this is tangent. Toa is the tangent of theta is opposite over adjacent. When I was your age, we didn't have a calculator that would do this. Yes, that's how old I am. We had a page. I had a paper that my math teacher gave me, and it had 4 columns. On the right-hand column, it had degrees. 1, 2, 3, 4, 5, 6, 7, all the way to 90. And then it had the sign, and it told you the sign decimal. And then it had the cos decimal and the tangent decimal. So you had to look up, if you knew your angle was 12, you would go down to 12, and you would look at the ratio. All these symbols and Greek letters and sine, cos, and tan, it looks like a lot. It's really not. It's really just that for a given angle, the ratio of these 2 sides, and these 2 sides, and those 2 sides, it's always the same. The ratio will stay the same no matter what size triangle you have. Because if I make this bigger, if I go out to here, if I make this triangle bigger, which side grows? All of them grow. And they grow by the same percentage. So the ratio between the 2 sides stays the same. That's really all trigonometry is. And all your calculator is doing is when you say the sine of 12 degrees, it's just going to the chart that it has stored in it, and it's interpolating that answer. That's all it's doing. So these 3 ratios are equal. Okay, that's fine, Mr. Espenhain, but we need the angle. So I can't plug the angle in here because I don't know the angle yet. Okay, so the reverse, if you're looking for the angle, you do the inverse sign of O over H, opposite over hypotenuse, and that will give you the angle. Okay, just do it in reverse. So on your calculator, you hit second sign or shift sign or whatever your button is. So it's cos -1 of A over H will give you the angle, and the inverse tangent of O over A will give you the angle. So take out your calculator, and let's try to find this theta. We know the 3 and the 4 and the 5. Hi Jude, I'm filming this for you. You did.
Oh, you are?
Yeah, I'm filming it for you. And for others if you want to go back and look at this. Okay, so how are you going to find this theta? What are you going to plug in your calculator? You can use sine or cos or tan. Let me, just out of curiosity, given the choice, how many of you would use sine? Only 2, 3. Who would use cosine? Nobody ever chooses poor cosine, except for Oliver. Good soul. Who would choose tangent? A lot of tangents. What about all you people who didn't put your hand up? What do you don't know? Put your hand if you don't know.
Randomly.
Put your hand up if what is trig? Okay, that's fine. Pick one. Let's do tangent because most of you said tangent. So you're gonna do the inverse tangent. So in most calculators you do shift tangent. And then instead of putting in, because we've done shift tangent, we're looking for the angle, you're gonna put in opposite over adjacent. This is our angle. Which side is opposite?
4.
Good. 4. So we're gonna put inverse 10, and then you're gonna do 4 divided by 3, and that should equal your angle.
Oh, I remember this.
If you have a graphing calculator that looks like this, the default setting for the angle is radians. So you need to press mode and then scroll down to where it says degrees and radians, and you gotta move it over. It's the 3rd row down, and you move it over to degrees, and then you hit enter, and then you hit clear, and then it'll work fine. So you do second tan, 4 divided by 3, and you hit enter. You should get, yeah. Oh, okay. Tina. Oh, okay, fine. Who has the answer?
53.1.
Gemma. Thank you, Nico. You're both right. About 53 degrees is what you should get. Now, you'll find if you do this with sine, if you do second sine of 4 over 5, because it's opposite over hypotenuse, you should find you get the same answer. And if you do cos, if you do second cos of adjacent over hypotenuse, so 3 over 5, you'll get the same answer again. You can do it any of the 3 ways. Okay, so we're gonna have this angle is 53 degrees. But how do we tell the helicopter pilot who's leaving from here to fly in the right direction? Well, we say this. We say they're 5 kilometers, and then you put a square bracket and you say 53 degrees north of west. Because you started at west and you kind of angled to the north. So this is north of west.
Oh, that's
Jude's
exactly.
narrowing his eyes. Gemma.
What if you say west is negative, but north is positive?
Oh, that's a good question. So the positive negative thing works if they're both in the same line, but as soon as you go like this, positive negative has no meaning because they're different. So this takes the place of positive or negative. There is another way of saying this though. If you wanted to tell the person from this way, you could do that as well. Would this angle be the same as this one? Or will it be different? This way. If we wanted to go from north, this is north, and this is west. How could you calculate that angle? Reza. Good, good. This is 53, right? This one is going to be 90 minus 53. What's 90 minus 53?
37.
Very good, Sarush. This one is 37. So you could also say 5 kilometers, 37 degrees west of north. Because you started at north and you went 37 degrees west. That is, either of those are the same and equal and fine. Yes, Jude?
On like a quiz or a test, would it ask for both, or would either answer be right?
Either answer would be correct. Yeah. You never need to do both. Does this make sense, kind of, sort of? Do you want some trig practice?
Kind of, sort of.
Okay. Let's just do a few examples here. Just to make sure you've got it. And if you're watching the video, do each one and then pause it and then I'll put the answer. Okay, here's a triangle. Give me a degrees. Give me a number. 35? Thank you, Parsa. And a number from 0 to 20. 10? Okay, find, actually let's do this first. Let's say this is 10. Tell me y and x. And we'll say this is 67. And this is y and z, and this is 4.2. So find the variables. And we'll do another one, we'll say z. So this is 2 and this is actually no, it's too big. So find the x and y, and then find the y and z, and then find z and find theta.
Oh man.
Go, team. Go. Yeah, you.
I solved it.
You did? You're done already?
No, I didn't even start.
Oh, okay.
We're gonna do something else.
So if you're watching the video, pause it here and try to figure these out. Anybody know this?
I just like forgot the like tan cosine and like the sin. Like, can you just write like the equations like tan is opposite over?
Sure.
Yeah.
What's the saying? Sokotoa?
I remember so. Oh.
It's kind of just in order.
Memorization.
Yeah, it's a mnemonic.
Oh, sorry.
Wait, bro. this one? What is this one?
Adjacent over hypotenuse.
You.
What's this one?
Opposite over adjacent.
What's the T for?
Tan equals.
Tan of theta. So the tan of the angle equals that.
Okay.
And if you want the angle, you do the inverse tan of this part.
Kish. Why is it me? Like I
I got it.
Bro, what?
If you are given the bottom number, so the hypotenuse is always the bottom, right? It's O over H or A over H. If you're given the bottom number, you just do the bottom number times the sine of the angle. Like if this is opposite, this is 10 times the sine of 35. Because this is the adjacent, you do 10 times the cos of 35. And that's going to be 8.2. That makes sense? Kind of, sort of. This is adjacent.
Dude. Stop it.
So for this one, you're going to say,
Oh, wait a minute.
you know that A, so you're going to do
Stop it.
A tan theta, which is
So you just sit in here.
9.9. And this one is going to be
No, actually.
like it's like at least like this. Yes. Is there anything else I should put in the video before I stop? Pretty good. You're very welcome. You're confused?
Yeah.
Okay, tell me why.
I don't know. It's okay. It's okay.
No, it might be useful.
I don't know. It's just.
Is it just because it's a lot, or is there
It's just
something
like,
specific?
I'm just still like new to it.
Yeah, it's a lot. Walk around with it for a bit and just
Okay.
keep practicing and stuff. It'll come. You have to kind of get familiar with it, right? It's a lot to do right at the beginning.